Hello, people. Ruby is there, and who is you again?
Me, Gloria.
Oh, Floria. You should use your name, right? Change your name. Let me change it here. Okay. Anna should be here too, I guess. She had been asking me to start the class long ago, but special student. Okay, Floria, how was your weekend? I can see you were here for. Was good?
Yeah.
Where did you go?
Well, I just stayed at home
Stay at
and
home.
relaxed.
I understand. Everybody stays at home. Ruby, say something, please.
Hi.
Yeah. How are you doing?
Fine.
Yeah. How is everything going with you, Ruby? Fine. Welcome, Anna.
Hello.
I thought you were waiting for me for a long time, right?
Me and Ruby.
You were waiting with Ruby for a long time. Okay. Have you downloaded this thing, the Kahoot app on your phone? Because
Yes.
we will use it tomorrow. We'll be using it a lot in our classes. So you should have the Kahoot app on your phone, okay?
Okay.
And also have your calculator and maybe any rough piece of paper or your notebooks so that you can do some calculations during classes. Okay. Before the other students come, we should get started. I will just start. I'll make a quick presentation for you guys, and then I'll tell you what to do, okay? I'll share my screen with you guys now. Okay, for today we are going to start with the second part of mechanics, which is about forces and motion in one dimension. In the previous lessons, what we have studied, mechanics can be divided into two major parts. The first part that we have studied already, we can call it kinematics. Maybe it's not necessary for you to know these words, but it's important to understand what we are doing. So we have studied kinematics, which is, it tells about to describe motion. How do objects move, right? Kinematics talks about describing motion. And then the second part of mechanics, which we are going to study from today, is called dynamics. Dynamics talks about why motion. It studies we talk about the cause of motion. So in this part, in the first part, the kinematics, we simply say, how do objects move, right? How do objects move? How objects move. That's why we have to talk about distance, displacement, speed, velocity, and acceleration. In this other part, which we will start from today, we are talking about why do objects move? Why objects move? Move. And to do this, the major word or words we are going to deal with, for this one, we talked about distance. We talked about displacement. We talked about speed. We talked about velocity, and we talked about acceleration and deceleration, if you wish. And for this part, the major things we are going to talk about will be force. And we are also going to talk about Newton's laws of motion. Okay? Okay? Are you guys there?
Yes.
Okay, okay.
So it's good. I just decided to present this map so it gets into your memory how we are going to deal with these things. So, force. What do you guys think is a force? Does anybody already know how to define a force? Anybody can speak. What is a force? Anybody can speak, huh?
Force is a rate of change of momentum.
Very, very good. You are too advanced. Yeah, you are the further math student. So in very simple terms, in layman's language, we say that a force is something that causes an object to accelerate. We say push or pull. You can push something or you pull that thing. If this is an object here, you can either push it or you pull it. And we have seen many different vectors, right? A force is also a vector quantity. This means it has magnitude and direction. You always have to have an arrow on a force, right? So if you push something or you pull, it will have direction, right? So we can use positive and negative for forces as well. If a force is moving in the, say, if you define this direction as the positive direction and you pull something this way, then that will be a negative force. We use F and we measure force in newtons. We measure force in newtons, N. So the unit is newtons. I would like to talk about many different types of forces. So you get this basic understanding. The different types of forces. So you can talk of an applied force. Applied force. If we have, like you have a car, something like that, or a cart, and this is you standing here. Let's say that is you, and you push this cart. Then the force that you supply to it is the applied force. In some books, they just denote it by F, or some people write F applied, but just F is enough. If somebody is also pulling, that is also an applied force. Or the engine of the car applies a force, that is the applied force. The second type of force I would like to look at is very important type of force is normal contact force. Before I talk about normal contact, I would like to talk about gravitational force. Gravitational force or weight. The weight of an object. So the Earth, if this is the Earth, and anything is near the surface of the Earth, then the Earth will pull that thing to itself. Any object near the surface of the Earth will be pulled towards the Earth by a force. This force is the gravitational force. Let's denote it Fg, or call it the weight of the object. And the weight of the object is the mass of the object times the acceleration due to gravity, which we know to be 9.8 or 10, right? And the third type of force I would like to talk about is the normal contact. Normal contact force, or just normal force, F normal. The normal contact force. So if this force is difficult to understand if we didn't study Newton's third law of motion. But I would just briefly state Newton's third law of motion here. Newton's third law of motion tells us that every forces come in pairs. If you have one force, you must have another force that is the same in the opposite direction. So let's say you have an object, a book is lying on a desk. This book has a force on it, which is the weight, always down. This weight that we have talked about, the Earth is pulling the book. But because this book is in contact with the table, it is touching the table. The book is in contact with the table. So the table will have another force on the book. The normal force, call it F normal, on the book. This normal contact, it will act on any two objects that are in contact with each other. Let's say the book was lying on an inclined plane. My plane is too inclined. Let me put the inclined plane like that. If your book was lying on this inclined plane like that, inclined at an angle, say theta, the weight will always act vertically downwards. But the normal contact force always acts at 90 degrees to the surface. That's why we call it normal. It always acts at 90 degrees to the surfaces in contact. So In other words, if I say, if this is a wall, the wall of my house, and let's say I am standing here, and I push on this wall, even just touch the wall is going to also push back on me. I push on the wall with some force, my applied force. The wall will also have a force on me, which is the normal contact force on me. All right, so any two surfaces in contact will have a normal contact force on them. That is a very important type of force. The next type of force I would like to talk about is friction. Friction will act on any two surfaces. If you have any two surfaces and they are trying to slide on each other, if you say, like say you apply a force here and this object will want to move that way, then because this surface is not smooth, it's rough, so there will be a resisting force. The frictional force, call it F friction. So friction always tries to resist two surfaces from moving against each other. All right? Is there any other force I forgot? Anna, we have talked about this in further math.
Yes.
What? One very important force. Tension. Tension. Very difficult to understand. It's a force that acts on a string or a spring. If this is a string, or a spring, if you pull, let's say you are here and you pull this string or you pull the spring, then inside this spring or inside the string, there will be a force. Remember Newton's third law. I talked about Newton's third law here, that forces always exist in pairs. So because you are pulling this, there is also going to be a pull on you by the string. That pull acts inside the spring, and this is called the tension. You can call it Ft or just T. I think in mathematics, we just denote this force T, not Ft. The interesting thing about tension is that tension will act in both directions in the string. It always acts towards the center of the string. So you have T here and you have another T here, and the magnitude is exactly the same. The directions are opposite, but the magnitude is exactly the same. You can think about it this way. If you try to pull on this string, then this object may also move this way. But what causes this object to move this way? It is this tension that pulls the object, right? So you pull, then there is a tension in the string in this direction. There's another tension this way, but this tension is acting on this object. This other tension here is acting on you. So it tries to pull you back, and it also tries to pull the object this way. So tension acts in both directions on a string. A very good question you would encounter in mathematics will be something like this. You have, say, an object is attached to a string and it passes through something we call a pulley. And another object is attached here. So this is a string here. And this string passes through, this thing is called a pulley. So you have an object, this is very smooth and it can rotate. So you'll be asked to make some calculations on this. First, label the forces. The forces acting in this case. We know that this will have a weight 1. This will also have a weight 2. And then there will be a tension in the spring or the string. There will be a tension up that way, call this T. If this pulley is smooth, it's not rough, then this tension will also have another tension here in that direction, exactly the same. So this is in agreement with this principle. I said tension acts in both directions on the string. This one acts that towards the center, that also acts towards the center on both sides of the string. All right. Is there another force I forgot? Is there another force I forgot? Anna?
Resultant force.
Oh, very, very good thinking. However, resultant force is not a type of force. We are saying that if you have an object and let's say you have a force this way, F applied, and another person is maybe pushing again this way, call this force F1. The first applied force, call it F1. Call this other force F2. Then, because these two forces are acting in the same direction, F1 will be positive. This direction is positive. F2 is also positive. This is the same as you have the object and you have one force. And that one force is F1 plus F2 in that direction. And this force is the resultant. This is the resultant of these two forces. Okay? Now, if, excuse me. If, let's say, you now have the object like that, and you apply F1 this way, and another person is pulling back F2 in that direction. Remember, force is a vector. So this direction, let's consider this direction to be positive because I can clearly see here that F1 is bigger than F2. The magnitude is bigger, right? So I choose the direction of the bigger force to be positive. And so F2 will be negative, right? So what is the resultant? Resultant force here is F1 again Let's use vector F1 plus F2. Resultant force is the vector sum of all the forces acting on the body, okay? The resultant force on any object is the vector sum. Remember, it's vector sum. You sum as a vector, vector sum. I didn't just say F1 plus F2. I said F1 as a vector plus F2 as a vector. Okay? Now, because F1 is positive and F2 is negative, this resultant force will be the magnitude. Because they are on the same line, they act on the same line, like the x-axis, so we can just sum their magnitudes, but this magnitude will be negative. So it will be F1 minus F2. This is the magnitude of the resultant force on this object. And this resultant force will be acting in this direction. So you have F1 minus F2 in that direction, since F1 is bigger than F2. Okay. Is there anything else I forgot? I'm very happy that you mentioned resultant force there before we can move on. Newton's first law of motion is the main thing to talk about today. And it's a very interesting statement. It just says that a body remains in a state of rest, or it will move with uniform motion. It remains in a state of rest. This means velocity is 0, or it moves with uniform motion. This means velocity is a constant. Velocity will not be changing unless it is acted upon by a force. I'll delete this and I'll write here by a net force. Any object will stay at rest, not moving, or it will be moving with constant velocity. This means the same speed with constant speed in the same direction, in a straight line, except there is a net force on the object. What is net force? Net force is just what we talked about here, resultant force. If the resultant force is 0, the object will be at rest or will be moving with constant velocity. Okay, let's illustrate that. If you have an object, this object here, if there is a force here, you have a force here, F, and you have another force here in that direction. If the magnitude of this is also F, the directions are opposite. These forces, the magnitudes are the same. The resultant force, let's call it F resultant, is F minus F, which is 0, right? The resultant force is 0. You think about it, if you pull something and another person pulls in the opposite direction with the same force, the resultant is 0. So Newton's first law is telling us that this object will either be at rest or will be moving with constant velocity. Okay? This object is either at rest or it is moving. Take note, it is moving with constant velocity. Moving with constant velocity. Okay. We have just about 10 minutes left. So what I would like to do within these 10 minutes is just show you what you should do next. There's not much to do. Download Kahoot. Okay, tomorrow we will have a short Kahoot game before we continue. The Kahoot will depend on what we talked about today. Go to the new course. This course, I have sent it in the group. Enroll in this course, and for today, you will watch all the videos on lesson 1. After you watch the videos on lesson 1, you will then download this worksheet, okay, at the bottom, and solve it. Remember, some of you guys have been having problems with this website, and the reason is that when you finish a lesson, you must click this button, okay? Mark complete. You see, you cannot move to the next lesson. You cannot move to the next lesson until you mark this button complete, okay? So when you finish watching all the videos and doing the exercises, click on this, mark complete, then you can move to the next lesson, all right? When you enroll in a course, you cannot start on a lesson in the middle. You must start from the beginning. And then you mark complete for the first lesson, then you can move to the second. Mark complete for the second, you can move to the third. Okay, you cannot just jump and go somewhere and study a lesson ahead. Understand? That's the problem some of you guys have been having. Okay.
So we need to finish all the questions in that worksheet.
Did you see the worksheet?
Yes.
There are 7 questions there. Please do them. But first, watch all these videos, okay? These videos explain better what I was talking about today. Okay? Watch them, even though it's a very simple things, but it's important that you watch them to get the good understanding of what we are talking about before you solve problems. Because if you don't watch, when the problems are changed a little bit, you will not be able to solve them. Any more questions?
Do we have answer?
Answers.
To check it. Yes.
That worksheet, there are answers, but I'm not going to give you the answers because I need to see. It's a worksheet. It's not exercises in the book. Okay? I will check your work. And then if there are any problems, we'll talk about tomorrow. Okay?
Okay.
Any more questions from any other person? Floria? I know you haven't studied mechanics before. Do you have any questions?
No.
Nope. Okay.
But I have some questions with the questions in the book.
With the first part of mechanics?
No, I mean the questions in chapter 2 in the textbook.
Oh, when we get there, we'll talk about them, okay?
Yes.
Let's go slow. Today, you are not doing anything in the textbook. Just watch these videos and then download this worksheet and answer them. And then when you finish, mark the lesson complete. Okay?
Okay.
All right. We will see tomorrow. Again, download Kahoot on your mobile phone and also come tomorrow with your calculators. Okay? See you